Thank you, everybody, for joining us. We are going to wait another minute or so just to give people a chance to catch up and chime in. Well, I've got a minute or so after our start time. We're going to go ahead and start. As I've mentioned before, either in a post or one of our Lumatronic posts, we want to thank everybody for attending today, for responding to either an invitation or seeing something online, or perhaps we have discussions going. I'm really thrilled to have a handful of some people that have really a lot of experience with this topic called Flex and the technology behind it, and in particular, the reel-to-reel production side of producing flexible printed circuits. I have Stefan Sandon from Montreal, along with our colleague Nicolas there. They'll be going through the technical side of the production line and covering things like the advantages, and we'll cover a little bit of an agenda in a little bit. Daniel Görike and Paul Sparenberg, our co-founder, are also online. They will be as a organizational note or housekeeping, will be supporting us in a Q&A session at the end also. So let it be known that during this entire presentation, feel free to use the chat, depending on what version you have of Teams or your operating system. Just chime in and you can start to ping out questions that we will then address after the technology overview. Um, let's talk about Flex here a little bit and take a quick look at the overall agenda for today. You will have access to this recording afterwards, so you'll get a follow-up emailing to that effect. I've covered a little bit of the introduction as to who we are as the people on board. We come with a very extensive background in the LED industry, all of us collectively in different parts of the market segments. And I'm only going to take a few minutes to just give you a snapshot introduction and overview to Lumatronics. We will then transition to getting right into what the reel-to-reel advantages are to an organization that's going to go from, let's say, a panel approach or even a rigid board PCB approach to reel-to-reel deployed in their manufacturing. How that process and production works in-house, some inside peeks and details. Stefan will then cover materials and manufacturing specifications to give you kind of a deeper feel of what's going on, the lack of having your hands on it, but knowing what it is you're building. And we'll also outline a capacity example so you kind of get a feel for the scale of working with reel-to-reel and what it means in that scenario. And then I'll jump back in at the end and cover a couple of added value processes that we offer and are a part of what we do. Let's take a look at Lumatronics. Who are we? Where did we come from? What do we do? We started in 2005 and were founded by co-founders Paul Sparenberg, who's on the call here and leads our sales and marketing and sales and client service team. And also Christian Hoffmann, our CEO, based in our factory there in Heschingen. We employ about 50 or so people, depending on workload and projects we have going on. We have our own secure building with some very unique characteristics I won't get into right now. And in 2024, we did almost 9 million euros at, let's say, in the 10 point something million US dollar range. And we are certified and really practice effective management relative to organizational structures and or processes, in particular also quality management and environmental management. So those three areas of occupational quality from a process standpoint and environmental, including our own solar system to power our facility to a great extent. Having started in 2005, we do see ourselves as LED specialists really from the start. We founded the company, Paul and Christian, and identified products and components basically in China and resold them here in Europe, predominantly, obviously, to start in Germany. But learned relatively quickly that there was a interest and demand for more specialized shall we say, higher quality and unique or custom LED products or subsystems. And so in 2008, 2009, we launched really a software hardware development team to not only get products built that we wanted for ourselves, but also for clients on a custom basis. And in 2010, made the commitment for our first production line right there here in Hechingen, Germany, about a half-hour, 40-minute drive south of Stuttgart, at the bottom of a mountain, by the way, with a castle on top, to do rigid bore PCBA assembly on a custom or for our standard products basis. And a decade later, in 2020, launched our own full automated reel-to-reel production line. And that's what we're going to really talk about. And over those 20 years that we've been around, we've developed a really unique and in a lot of cases, strong relationship with a partner network, which I'd like to just highlight very briefly right here now. In the process of producing FPCBA or even PCBA products or assemblies or modules for clients, we offer established relationship and understanding of the product base and the organizations that really, by and large, cover the important players in the LED business. You can see the names there, in particular bulb for specialized UV applications, and in other areas like optics and power and connectivity with folks like Kasambi, ERP, and the optical lineup from Ledl, Carclo, Gajan, and Ari, or Ingemann. So we are always naturally prepared to work with any of your suppliers and with specific, per the specifications of a project, but we bring this history to the table in the services we provide, which sometimes often can help for the devil in the details like procurement, supply chain, and things like that. So at this point, let's dive in and take a closer look at the production line. And I'm going to hand it over to Nicolas here. Nicolas joins us with experience not only in the component and distribution side, but also on the OEM side and on the engineering and services side. And he'll be followed up by Stefan. Thanks, Nico.
Thanks, Jean-Michael. So yes, diving in the webinar topic, here is how the reel-to-reel equipment looks like. It's a fully automated line from the PCB and LED reels, component reels, to the flexible ball reels. This is why it's called reel-to-reel process, and it's allowing automated and continuous production, leading to greater efficiency and potentially higher output on competitive cost. So now the different advantages of the reel-to-reel production. So the reel-to-reel production of LED strips offers several advantages over traditional method, primarily in terms of cost effectiveness, efficiency, and reducing labor cost and assembly expenses. Furthermore, reel-to-reel eliminates the need of the manual soldering, which is very key, can be a weak point in traditional LED strip production, leading to a more reliable and durable product and better mechanical accuracy over the full length compared to panel-to-panel soldering process. The advantage of this method is really the continuous substrate, which is unique. Unlike the usual panel-to-panel build, there is no weak point on the LED tape, leading to dramatically reduced chances of failure. There are automated checkpoints in addition within the line throughout the entire process of production. This way, any irregularity or issue can be fixed, identified, and corrected before shipping the product to the end customer. The reel-to-reel product can be cut to fit, bent, or shaped to fit a complex surfaces, making them ideal for application where precise curves and specific lengths are needed. One part number can replace several different rigid PCB size and also handle with no defect the possible uniformity issue in brightness with different lengths of PCB connected to the same driver, as in this process we guarantee that in this manufacturing process only one LED reel are going to be populated on one LED flex reel on the output, which is unique. Regarding the space and the storage, one flex LED board of 164 feet can replace several different boxes of rigid board with different lengths, especially with the 4-foot length board and with multiple possible voltage binning that needed to be separate in the warehouse is taking a lot of space. Reel-to-reel strips are lighter and smaller than rigid board, resulting also with cost-effective shipping even from overseas in Germany. By replacing the mounting method by not using screw anymore but only adhesive, it's less labor intensive for the assembly. So it's also reducing cost. And at the end, connector or soldering pad are used by the end customer to connect the LED board to the driver. So this is basically how this line looks like. It's a full automated continuous line dedicated to reel-to-reel manufacturing process. The line is 69 feet long. It's very long, supporting from roll of flexible PCB, so the starting point, to roll up finished LED flexible board in reels following this continuous production process. So here are more details on each step of the production line. The step one, the first step, is the roll-off process, and this process can handle various widths and lengths of FPCB with a maximum of 150 kilograms. Now step two, this process enables the label printing for full quality tracking. So this is based on a fully configurable inkjet printing system for marking all customer-specific requests lane by lane, such as barcode, batch number, customer part number, logo, counter, etc. Then step three is the fully automated solder paste printing system, which is enabled up to 610 millimeter length and optimize cycle time in few seconds. Then on step four, we have the pick and place high-speed equipment for LED connector IC, like ESD protection diode, for example. And this machine is able to place up to 52,500 components per hour. Step 5 is very important. This is the oven. In that case, it's an infrared heating element with a zonal temperature measurement and control with separate heating element. It's very, very efficient and compact size compared to traditional oven. And this oven is key element in the speed and the quality of the assembly, as you cannot use a traditional oven for this kind of manufacturing process. So this step 6, is optional. It's AOI and light up test that the customer can specify in order to have contact adapter to a functional test on the line directly. But most of the customers are not using this option, because it's reducing the speed and it's costly. Because at the end, if they are laminating adhesive, they are doing the functional test after it's been with the lamination of the adhesive on the back. Now it's step number 7, and this is a programmable X and Y cutting system. It can do linear cutting or freeform cutting possible, but remember that freeform cutting is reducing a lot the speed of the equipment, so it may not be suitable for this many application. And this is the final step in the process. Okay, so this is the cut and splice function to the end, and it ends up with a fully functional flexible board strip in reels. And reels, again, are typically 164 feet, which is 50 meter roughly, which is much more than the traditional 5 meter that most of the people are selling in the market. So just remember that because it's a continuous process and all those operations are not taking the same time and the production doesn't stop, it's a continuous process again, we need multiple buffer in the line to speed and able to support this continuous manufacturing process. This is another secret of the line in order to be able to do this continuous process. So at the end, as we already mentioned, one mounting option that commonly used by people is to laminate adhesive tape on the back of the PCB. This is done as a post-processing process on each reel. We can laminate up to 45 tape width with recognized brand as 3M for the adhesive itself. And this is very powerful system in order to put the adhesive on the back of the reel, each reel. Okay. So this is the end of the production line details explanation. And now we'll speak more about the material specification, handing up to Stéphane.
Thank you, Nicolas, for explaining the reel-to-reel process, and also thanks to everyone for attending. We really appreciate it. We'll now talk briefly about the material we use, the basic specification we will ask and why, and a word on quantity we do per production, which impact, the multiple and MOQ that we will talk about when we discuss your project, as well as an idea of overall capacity. So if we start with the flex material itself, you see on this slide the construct. It's basically a fine layer of a polyamide base material, typically 25 or 50 micron. Actually, 50 micron is very often used, over which we laminate a copper layer. Could be 1 ounce, 2 ounce, 3 ounce, as per a North American standard. Typically, we will use 2 ounce. In more demanding application, we'll go 3 ounce. And finally, on top, you'll have either a coverlay or a solder mask. For those not familiar with the topic, coverlay is a solid film applied to the surface, as a solder mask, which is similar to standard PCB, is a liquid applied to the surface and cured afterwards. So that is for a single layer. As for a second layer, a 2-layer concept we use when we have, for example, a high count of channels like RGB, things like that, more complex circuit. One layer is not sufficient anymore. We go to 2 layers. It's really basically the same as one layer, with the exception that you now have an extra copper layer at the bottom and an extra protection layer at the bottom. So that's basically a 2 layer. A word on thermal performance, as the question is often asked. To start with, polyamide has by nature a better conductivity than FR4 per millimeter. And millimeter is key here because we're talking the same thickness. And that's where our process, the flexible circuit, has an impact, because our polyamide layer is very thin. It's like 30 to 60 times thinner than what you get in the usual board. And the thermal pad is more direct and is better. Polyamide is also is also a more capable material in terms of high temperature than FR4, which leaves, comparison to metal core. We believe the thermal performance is actually closer to metal core than FR4, but we're in the process of quantifying this with internal tests, and the results should be available by end of the year. So we'll be able to talk about real numbers if you have like question in that regards. But the overall idea is that much better than FR4, very likely closer to metal core in terms of thermal dissipation. A bit more on the basic specification, so you have an idea of what we're talking about when we discuss your project. As Nicolas mentioned, we use a very long flexible PCB on what we call internally a drum. This drum is usually 50 meters long, but could be 100 meters, could be customized. The width of that PCB is typically 250 millimeters or 500 millimeter. On the screen, we talk about usable. We use a margin on the side as reference for the whole line to synchronize itself as it moves along. So that leaves us 230 millimeters or 480 millimeters on these drums. And we only have the narrow one for 2 layers. But most cases, we're using 1 layer. A bit on the production image. A production image is basically how long are the steps in the assembly line as we process it. It could be up to 610 millimeter, almost pretty much 2 feet. And it's case dependent, so we need to validate everything for each project. But really what that means, it's define how many repeated circuit we can do at every steps. It also represents the maximum length we can do of a single repeated circuit. So if your unit circuit is longer than 2 feet, then we'll need to discuss with you what needs to be done to actually adapt the circuit. But we actually haven't really seen that scenario yet. So, but just to give you an idea of we're working in step into the production line. As Nicolas mentioned, one of the last steps is to separate the larger drum into final reels. One thing to take note here is the width of the strip is very important, because the narrower the strip, the more strip we produce at the same time. So if we produce more strip at the same time, the better the price is. Something to keep in mind. As a quick example, if we do a 10 millimeter strip on a 2-layer circuit, using a 250 millimeter drums, which is 230 millimeter usable, then we would have 23 strips. We often call them lanes of 50 meters each. That will give you 1,100 meters, or a bit less than 4,000 feet per production. If we do a quick recap, again, like I mentioned, the PCB itself, 50 meter long typically, could be 100. The width is 230 usable or 480 usable for higher volume type of demand. We have a production image to deal with. And if we make another quick calculation of what we do per production, and by the way, each production determines the multiple and the minimum quantity order. So if we take a one layer option for high volume and on a 10 millimeter strip, we would do 48 strips per each of them 50 meter would give you 2,400 meters or a little less than 8,000 feet. And if we reuse that number in terms of actual production capability, on a 3-shift basis, that would represent 7,200 meters. So 7 kilometers per day, 23,000 feet per day. And over a year, then we'll be talking about 18,000 kilometers per year and 1,100 miles per year. So we can take a lot of production. You know, if you have big production in mind, it's not a problem for us, and we can actually take the challenge. And that's basically it. I guess I will give the control back to John Michael.
Thanks, Stefan. Appreciate that. I'm only going to take a few minutes here and a handful of slides just to highlight some post-production line processes that we do for clients. Some of them want the entire 30 to 50 or longer or 50-meter reel. Others want, in some ways, for us to make things easier, whether that's customized lengths, let's say, or as making a module assembly by attaching cables or other elements to an FPC. We can also take the next step and build those into either a finished fixture or sub-assemblies to create for you, including things like lenses, which typically we'd use a gluing methodology. But along the way, there's also in your project things that we can do even at the FPC substrate level, like having perforations in there so you can actually not, tear them or build them to your size, which is not so much relevant with cutting points or segments in a typical LED strip, but perhaps your FPC is actually a sheet of something. So having said that, there are all kinds of things that we can discuss as a project starts and a relationship develops. There's another area that I'd like to just touch upon because I think it's an extremely exciting area, something that we invented and developed the process here in Hechingen, Germany, for taking flexible assemblies perhaps the next step, and it's our product and process called Loom Protect. And fundamentally, it's a lamination process using very high heat and high pressure to encapsulate a module or flex strip and give you a net result that I'll just take a quick slide through on the features, resulting in something that works better than a typical potted or such IP67 approach, giving you really resistance to chemicals and liquids and mechanical influences. Let's take a quick look at those feature sets or net result. IP67, depending on the particular application, with a warranty in the, I believe, 3 to 5 years. A product that is going to be very resistant to various chemicals, salt and other chemicals like cleaners, for alcohol, for example. Probably the two key benefits of this approach of reaching IP67 in comparison, especially to potting or other silicone approaches, is a very high efficacy on the light output. The material is very transparent, minimum in the 96%. And subsequent to that, a much lower impact of color shift that happens typically when you pot or encapsulate an emitter platform or source. So obviously the colder colors will see a little bit more impact than the warmer range. Because of the process of really these isolated layers, the isolation layers, we have a high dielectric strength to it. So some things that are really important for certain kinds of applications. And we can do a fairly large areas like sheets or panels. We can't do an entire 50-meter roll, but we can also do it with elements to it that are either cosmetic desires or application or functional, like having a structured or smooth surface to it, or having a backing to it of either different colors or different materials, be it a textile or maybe even a rubber, a composite or something like that. And when we build an entire module, we can include those other elements that I spoke about in a non-Loom Protect application of adding cables and using things that some connectors, shrink tubes, solder connectors. We can make all of that as a part of it. I want to take just a real quick look at the process itself and what it is that happens. We're actually going to have in the near future, coming soon, a webinar just on Loom Protect, where we dive into this a little deeper. And if this is of interest, certainly get a hold of any of us. But as I mentioned, it's a system we've developed and innovated that with high pressure and temperature really essentially melts that whole thing into one. And after that process, immediately being cooled. The makeup of that is very flexible, but essentially you're taking your flexible board and having a layer above and below it with a protective layer then on top. And should you want a textile backing or other type of material, that's possible. And you might say, well, what for? Well, what if you wanted to add a Velcro to the back of the FPC, or sew it into clothing or tents or other quick and easy applications? The application of flexible printed circuits is really becoming diversified even beyond just general lighting. Now, all of this might have been a little bit overwhelming from a capacity standpoint. Do keep in mind, as we started with products, we've also developed and maintain our own portfolio of standard products that you can buy in 5-meter roll or even larger. And we have key platforms to play with, to look at, and to use. And let it be also known that in particular, Stefan and Nicolas are working diligently to be able to say that, and I'll say it up front, we have some exciting developments in the works for the constant current platforms also, which is predominant here in North America. But there are options to work with, and in addition to products that we develop or we produce on our reel-to-reel line, we have modules, connectivity products, and firmware and such that are all a part of the ecosystem for your solutions. Okay, I want to say thank you again for everybody that did take the time to join us. Thank you from our entire production line. Special thank you to Nicholas and Stefan and Daniel for chiming in, who's going to, at this point, I haven't even looked. I don't believe we had really that much as far as questions. We will certainly hang on here a little bit. All five of us are really, to a great extent, focused on serving the North American market. I know on this call we had one or two people actually in European, perhaps wanting the English instead of the German version of our Meet the FLEXPERTS. But we'll sit tight here for a moment should any questions pop up here. Follow us on LinkedIn, and we've also newly established a presence on YouTube. We welcome the chance to hear from you and follow up to today's webinar.
Yeah, also thank you from my side. So I am having a quick look at the Q&A section. So far, we do not have any questions, which is, I guess, good. So we explained everything properly. If you have some questions, feel free to use the Q&A button, the second one next to the chat option. So we're just going to stick here for a couple, 2-3 minutes in case there are some questions. And if not, then have a nice day or evening, depending on where you are. And thank you again for participating.
Thank you, everybody.
Okay. Doesn't look like there's any more questions. So
John, I appreciate you joining us today. Let's touch base anytime we can. Thank you for taking the time.
Okay. Then goodbye.
Thank you.